Hi everybody, this is the continuation of section 2 of chapter 3 where we're going to wrap up our section on compound interest, and we're going to start with this thing called the average percentage yield. And the average percentage yield is a tool or a metric that you can use to compare different types of investments or different types of loans with different rates and different compounding periods. And basically, the average percentile yield is the simple interest rate that will produce for you the same future value that a particular loan or investment will make in exactly 1 year. And if you do the math with the compound interest formula, or if you do the math with the continuous interest formula, the average percentage rate can be expressed, or the average percentage yield can be expressed by this expression for investments that are compounded at certain times out of the year, or for this investment, or for investments where they are compounded continuously. And sometimes the average percentage yield is also referred to as the effective interest rate or the true interest rate. So here we want to find the average percentage yield for two different types of investments. We have Southern Pacific Bank that offers a 1-year CD that is paid 4.8% compounded daily. We're going to assume that 1 year is 365 days. And then Washington Savings Bank offers a CD that pays 4.85%, a higher rate, but it is only compounded quarterly. And we want to find the average percentage yield for each one and determine which one has the highest return. Okay, so since we don't have continuous compounding, the equation that we are going to use for this is APY is going to be equal to 1 over R divided by M raised to the mth power minus 1. Now for Southern Pacific, I'm going to call that SP, we have that R is 4.8%, which as a decimal is going to be 0.048, and M is going to be 365 days because we are going to assume that there are 365 days in 1 year. Okay, and with that we will have that the APY is equal to 1 plus 0.048 divided by 365 raised to the 365 power minus 1, and that will give us a value of 0.049167. Now remember, we are going to the and now remember, this is a decimal. To convert this into a percentage, we need to multiply this by 100. And then that will give us an APY of 4.9167%. And since we want this to 3 decimal places, correct the 3 decimal places, we are going to put in 4.917%. So that is Southern Pacific. What about Washington Savings Bank? We'll call that WSB. Well, there the interest rate is 4.85%. Which can round to 0, which as a decimal is 0.0485. And they are compounding quarterly, so M is equal to 4. So for these guys, the APY is going to be equal to 1 plus 0.0485 divided by 4 raised to the 4th power minus 1. And if you knock that out in your calculator, you are going to get 0.049392. Now this is not this is a decimal, this is not a percentage, so we want to multiply this by 100%, and then that will give us 4.93892. We want this to the third decimal place, which is, and 9 is the fourth decimal place. So this will give us an APY of 4.939. Which one has the highest return? Washington Savings Bank has the highest return. That's the one that you're probably going to want to go with. Now, in some particular cases, you are going to be given your average percentage yield, and you're going to need to figure out the nominal interest rate. And that is what we are going to do here. Okay, so let's take a look. So here we want to compute we want to find the average nominal rate. In other words, we want to figure out what R is, given that we are compounding quarterly. So M is equal to 4, and we have an API of 5.8%. Okay, so if our API is 5.8%, we can't work with percentages. We have to convert this to a decimal, and we can do that by dividing 5.8 by 100. And that will give us an API of 0.058. And our equation is going to be that the APY is equal to 1 plus R over M raised to the mth power minus 1. So with our substitutions, we are going to have 0.058 is equal to 1 plus R over M, no, I'm sorry, R over 4, because M is 4, correct? R over 4, R over 4, raised to the fourth power, minus 1. Well, the first thing that we can do is we can add 1 to both sides. Plus 1 here, plus 1 here, and that will give us 1.058 is equal to 1 plus R over 4 raised to the fourth power. Now, what the heck can we do here? Well, this is what we can do. Let me rewrite this over here. 1.058 is equal to 1 plus R over 4, all of this raised to the fourth power. And what we can do is we can take the fourth root of both sides. And taking the fourth root is the same as raising this to the 1/4 power and then raising this to the 1/4 power. Now, if you remember way back about your property of exponents, one is called the power property. And if we actually have exponents that are outside of a grouping symbol like this, they multiply. So on the right hand side, we are going to have 1.0, I'm sorry, the left hand side, we're going to have 1.058 to the 1/4 power. This is actually the fourth root of 1.058. And over here, we are going to have 1 plus R to the fourth to the 1/4 power, and that will just simply be equal to 1 plus R to the fourth. Whew, I know what you're thinking. Wow. Okay, now I can subtract 1 from both sides, minus 1 here, minus 1 here, and I had to be careful because all this is inside a grouping symbol. So on the left-hand side, you're going to have 1.058 raised to the 1/4 power, the fourth root of 1.058, minus 1. These will cancel, and this will be equal to R divided by 4. And then finally, we can multiply both sides of the equation by 4. Can multiply this by 4, can multiply this by 4. All right? And then these cancel, and you're left with R. And then for this part, you're going to have 4 times the quantity 1.058 all to the 1/4 power. Well, not all, it's just that one term there. So that's the fourth root minus 1. And that is what you would need to knock out on your calculator. Yeah, wasn't that fun? And this will give you an interest rate as a decimal of 0.05677 9, and some more. We want to multiply that by 100%, and then that will give you the answer that we're looking for, which is that R is equal to 5.6779%, which will round to 5.678%. And now it is time for applications. And we actually did some of these in chapter 2, so we're just going to go ahead and do them again. Of course, I forgot something. What did I forget here? We're compounding daily. I had to specify the number of days in a year. We're going to go with 365. And our first question is here: how long will it take for your money to double if invested at 9% daily? Now notice that we did not specify P. We don't have to. In this particular case, we can actually solve the problem without knowing what P or without knowing what A is. Okay, because, well, if P is, P, then A is going to be equal to 2 times P. And then the P will magically disappear, as I'm about ready to show you. Okay, so since we're compounding daily, we are going to use this equation here. A is equal to P times 1 plus R over M, all raised to the M times T power, and it is T that we're looking for. Okay, so for part A, we know that R is 9%, which is equal to 0.09, and since we're compounding daily, we know that M is going to be 365. Okay, now A is going to be, and A is equal to 2P. Okay, well that means that we're going to have that 2 times P is going to be equal to P times 1 plus 0.09 divided by 365 raised to the 365 times T power. Now notice the P's cancel. This cancels here, and then we are left with 2 is equal to 1 plus 0.09 divided by 365. That quantity will then be raised to the 365 times T power. All right? Now, what we're going to do now is take the log of both sides. And if we do, we are going to have that the log of 2 is equal to the log of 1 plus 0.09 divided by 365, all that raised to the 365 times T power. Okay, now remember from the property of logs, this is going to be equal to 365, okay, times the common log of 1 plus 0.09 divided by 365, and all of this is going to be equal to the log of 2. I forgot the T here. T is kind of important since that's what we're looking for. Now I can divide both sides by 365 times the common log of 1 plus 0.09 divided by 365. Okay, these will cancel. These will cancel. The only thing I have left will be a T. And then over here I have the common log of 2 divided by 365 times the common log of, you guessed it, 1 plus 0.09 divided by 365, and that will be equal to 7.7 years. 7.7 years. Okay, unfortunately, I don't think I have enough room to do the other one. Well, maybe I do. Let me see if I do. If I do, great. If not, I'll just do it again somewhere else. Okay, so for the next one, for part B, I'm going to do that in blue. We have 7% compounded annually. Now the equation for that is going to be that A is equal to P times E to the RT. In this particular case, R is going to be equal to 7%, which as a decimal is 0.07. You divide 7% by 100, that's what you get. Okay? And that's pretty much all. And once again, a is equal to 2p. So making the substitutions, we are going to have that 2 times p is equal to p raised to the e to the 0.07 t power. Once again, the p's cancel. And we have that 2 is equal to e to the 0.07 t. Now I'm going to want to take the natural log of both sides. And if I do, I'm going to have the natural log of 2 is equal to the natural log of e to the 0.07 t. Using the property of logarithms, we can write the right-hand side as 0.07 t times the natural log of e. And of course, that's going to be equal to the natural log of 2. Okay, well, the natural log of e is just simply 1. Okay, and that means we have the natural log of 2 is equal to 0.07 times t. So I can divide both sides by 0.07. These cancel, and I will have that t is equal to the natural log of 2 divided by 0.07. And that will give us that t is equal to 9.9 years. Okay, so it turns out that even though we're compounding continuously, the reduction in the interest rate causes us 9 years to double for our money to double. Okay, for this problem, we are being asked what annual nominal rate, compounded monthly, has the same annual percentage yield as 8% compounded continuously. Okay, well, remember for continuous compounding, the annual percentage yield is equal to e to the r minus 1. For compounding monthly, the annual percentage yield is going to be equal to 1 plus r over 12, since we're compounding monthly, raised to the 12th power minus 1. And notice that here we want to have the same annual we want to have the same annual percentage yields, and that basically means that these two equations must be equal. So we are going to we also need to mention that this is different. Okay, so this is the interest rate for the compounding continuous case, and then this right here is another interest rate. So let me just call that r tilde for the time being. Okay, so these are going to be equal. So what we're going to have is that e to the r minus 1, you want to set equal to 1 plus r tilde minus 12 raised to the 12th power minus 1. Okay, what else do we know? Well, we know that the interest rate for the compounding case is 8%, so the r is equal to 0.08. That's 8% divided by 100. So we can write this as e to the 0.08 minus 1 is equal to 1 plus r tilde divided by 12 raised to the 12th power minus 1. Okay, well, we have minus 1s on both sides. We can cancel those out, so those are gone. And then we are left with e to the 0.08 is equal to 1 plus r tilde divided by 12 raised to the 12th power. Okay, now I want to take the 12th root of both. I want to take the 12th root of both sides. So I'm going to raise each side to the 1/12th power. The 1/12th power. So 1 over 12 here, and then 1 over 12 here. Okay, and that is going to give me e to the 0.08 raised the 12th root of that, and we can actually compute that. It's just basically raised to the 1 over 12 power. And that is going to be equal to, now once again, using the power properties, we're going to have 1 plus r tilde over 12 raised to the 12th power, all of that being raised to the 1/12th power. So since we're going through grouping symbols, these will multiply, and this will be 1 plus r tilde divided by 12. Okay, if that's the case, we can subtract 1 from both sides, and we will have that r tilde over 12 is equal to e to the 0.08 power, or the 12th root of that, minus 1. And then finally, r tilde is going to be equal to 12 times the quantity e to the 0.08 power, that raised to the 1/12th power, the 12th root, minus 1. That will give you that r, I'm like going in various circles here, is equal to 0.080267. Now remember, this is a decimal. I need to multiply this by 100%. And then that will give me my final value, finally, which is r is equal to 8.027%. Because we have a 6 here, the next digit is a 7. It causes us to round up, and that is our value. So yeah, that is just a little hairy, isn't it? And now we have 2 more examples. Here is the next one. And here we have a newborn child that receives a $10,000 gift towards a college education from her grandparents. And the question is, how much will that $10,000 gift be worth in 17 years if we are compounding quarterly? Okay, well, that's pretty much that's nothing more than the straight A is equal to P times 1 plus R divided by M raised to the MT power. Once again, our P is $10,000. Our interest rate is 10%, which as a decimal will be 0.1, and T is 17 years. And since we're compounding quarterly, M is equal to 4. So just do our substitutions. A is equal to 10,000 times 1 plus 0.1 divided by 4 raised to the 4 times 17 power. That will give us that A is equal to $10,000. 0.1 times 4 is 0.025, plus 1 is 1.025, and that is raised to the 68th power. And that will give you a value of $53,607.165. And in dollars and cents, that will be $53,607.17. Now the last example kind of tracks with the last collection of problems in your homework, and I have a suspicion that the numbers are slightly different, so you probably don't need to pay attention to whatever is on the slides. And actually, we're not using that. We're going to use this instead. So here we have a girl named Jill. She deposits an initial investment in 4 different bank accounts as follows, and we want to determine which account is going to reach $10,000 first. Now to do this, we want to use the interactive figure. That's this thing right here. So we're going to click on that. And this is our interactive figure as soon as it finishes deciding to load. Okay, so notice that we have an investment goal. We want to know which one reaches $10,000 first. That's our investment goal. There it is. We have an initial deposit for account A. Our initial deposit is $2,000. So we want to put in $2,000 here. Okay, we have a rate of 6.5%. And we have one compounding period per year, so we're going to put that in here, enter, and there we go. It turns out that we will reach $10,000 in 26.56 years. So we probably want to write that down somewhere. So let's bring up OneNote. Don't need that anymore. So we have that for account A, 26.56 years. Okay, let's get back to where we were. Okay, now let's take a look at account B. For account B, we are going to deposit $2,900. Our interest rate is 6.75%. And we are going to have 12 compounding periods per year. And we are going to reach $10,000 in 18.39 years. Okay, so actually let's kind of do this. Let's bring OneNote up. Let's actually make it smaller. And we can just go ahead and put that right here. And okay, so for B, we have 18.39. So B is going to be 18.39 years. Okay, C. We're gonna start off with $3,100. No, that's our investment goal here. $3,100. There we go. The interest rate is going to be 6.25. And we are compounding 4 times per year. So this is probably not going to be much better. This is probably not going to be any better. And that gives us 18.88 years for C. And now we have D. For D, we are depositing $3,200. Interest rate is 5.5%. That's pretty pathetic. But we are compounding weekly, so that's 52 times per year. And that gives us a result of 20.73 years. So D is 20.73 years. The question that we are being asked is, which account will reach 10,000 first? And it looks like B will. So we're going to go ahead and click on B. Click check answer. And goodness gracious, we are correct. Okay, so let's take a look at the other one since we are here. Here is question 8. Suppose you wish to deposit initial investment on an account that is earning 6.25% annually, annual interest compounded monthly, so that is worth exactly $17,000 in exactly 13 years. How much? Determine the initial investment that would most likely achieve that goal. Now, we can do the math, but we don't have to because we get to use our interactive figure. So actually, let me try it like this. Let me bring this over here. Let me launch our interactive figure. Well, here it is. And the question here is, which investment will most likely achieve that goal? And actually, I kind of already figured it out. This is how we're going to do it. Now, our goal is $7,000. So we can put $7,000 here. We don't know what our initial deposit is. We know that our interest rate is 6.25%, so I'm going to change this to 6.25%. And we know that we are compounding monthly, so that is going to be 12. Okay, that's not 12, that's 17. So what we want to do is we want to check each one of these answers and see which one of these is going to give us the number closest to 13. So let's go ahead with putting in 2653. 2653. That gives us 15.56. Let's take a look at C, which is 65.63. 63, not 65.63, 65.63. That gives us 1.3 years. I guess that would make sense since it's only $500 off of $7,000. Let's try, so that's not very close to 13. Let's try 21.73. That gives us 18.77 years. And then finally, if we try $3,113, we get exactly 13 years, which is why we chose that one. Okay, moving on. Okay, here's another one. Suppose you want to borrow $50,000 at 3% annual interest with 12 periods per year. You have the option of paying the loan over a 5-year or 10-year period. Compare the values of each payment and the total number of payments for both loan periods. And once again, we need to use an interactive figure. Well, here it is. This is actually a different one. So this is our loan analyzer, and our loan amount is $50,000, so that's how much we want to put in here. And what we want to do is we're going to use this to figure out what our payments are going to be. Okay, so here we have $50,000. Our interest rate is 3%. Our compounding frequency is 12, so that's going to go there. And we want to see what our payment is going to be for the 5-year loan. Okay, so here number of years is going to be 5. Okay, and this down here is our payment. Our payment is going to be $898.43. We should probably write that down somewhere. So for the 5-year loan, our payment is going to be $898.43. Okay, so now we want to do the exact same thing for the 10-year loan. And what we're going to do is we're just going to go over here, and instead of having 5, we're going to change this to 10. Okay, and then for our 10-year loan, our payment is going to be $482.80. And they are asking to go compare to the 10-year loan. Each payment in the 5-year loan is going to be X number of dollars greater. Well, that's just going to be $898.43 divided minus $482.80. That is going to give a difference of $415.63. So that's what we want to put in here, 415.63. And there we go. Oh, that's the next part. Compared to the 5-year loan, the total payments for the 10-year loan will be X number of dollars greater. Okay, well, let's come back over here. This right here is the total number of payments you are going to make for the 10-year loan. And that is going to be, because you're basically, even though you're making less payments, you're making twice as many payments. So the total amount that you are going to pay into your loan is going, for 10 years, is going to be $57,936. For the 5-year loan, the total your total payment, or the total of all your payments, is going to be this. Once I get the 5 in there, is going to be $53,905.80. That difference is going to be $4,030.20. Okay, and is that right? That is correct. And so there you have it. Even though you have to pay more per month for the 5-year loan, the total amount of money that you will end up paying is going to be $4,030 less, because you're making fewer payments. And that is one of the biggest trade-offs when you're actually dealing with loans is, well, how much can you afford on a monthly basis? Because if you can afford more on a monthly basis, you will be paying less overall. Okay, so this is the last one. I know I'm kind of killing this video, but let's go ahead and just knock this out, so at least you have an idea how to do this if you need it. So suppose you want to take out a loan for $10,000 at an annual rate of 7% compounded monthly. If you want the payment to be as close as possible to $100, how long should the period of the loan be? Well, once again, we're going to be using, I don't think we're going to be using this tool. We're going to be using the loan analyzer. Oh, actually, it is the same tool. Okay, so we are going to take out a loan for $10,000. Okay, so the loan amount is $10,000. Right now that's a 100,000. Let's make it 10. There we go. The interest rate is going to be 7%. We are compounding monthly. Okay, now we want the term of the loan to be adjusted so that our payment down here is 100. So let's take a look at this. Let's first look at 18. Okay, if the term of the loan is $18, we only have to pay $81.55 per month. So we probably, and we're looking for 100, so we probably want the term to be less. Let's take a look at 13. Oh, I didn't want to do that. That's a mistake. Let's take a look at 13 over here. Okay, that gives us a payment of $97. That's only $3 off, so it's close. So maybe, so we actually want to decrease the term of the loan even more. So we tried 13, it's still too low. Let's try 10. And that gives me a payment of $116. So that is $16 over 100. Let's go back to 13. That is $2.19 below 100. 15 is not even going to be close. I didn't want to do that. 15 is not going to be even close. So 13 years is 13 years is the term or the duration of the loan that will give us a payment closest to $100. So our choice is going to be 13. And I actually did it right. Yay me. And that is pretty much how you do all of your application problems and use this particular tool. And that is all that I have for this video. If you have any questions, please feel free to contact me. This is Bob Boyle.